What if the biggest threat to astronauts was something they couldn't even see? Welcome to the mysterious and boundless cosmos, a realm of infinite wonders and unseen perils. Our journey today takes us beyond the protective embrace of our Earth's atmosphere, to confront a silent and invisible menace that lurks in the vast emptiness of space: radiation. Radiation in space is not like the radiation we're familiar with on Earth. It's not the result of nuclear power plants or medical X-rays. No, this is cosmic radiation, a relentless stream of high-energy particles that comes from the sun and distant galaxies. These particles are so tiny, so elusive, they pass right through the walls of a spacecraft, and even through the human body, unseen and unfelt. But don't be fooled by their ghostly nature. These particles carry an insidious threat. They're like tiny bullets, zipping through space at near light speed. When they collide with an astronaut's body, they can damage cells, disrupt DNA, and lead to long-term health issues such as cancer and degenerative diseases. It's a silent, unseen battle, fought on the smallest scales, yet with the highest stakes. And it's not just a concern for astronauts. As we dream of establishing colonies on the Moon, Mars, and beyond, we must confront the reality of this invisible threat. Our ambitions of becoming a spacefaring species are tied inextricably to our ability to understand and mitigate the effects of space radiation. Yet, despite the dangers, the allure of the cosmos remains irresistible. The promise of discovery, the lure of the unknown, the thrill of exploration, these call to us, beckoning us onward, even in the face of unseen perils. But what exactly is space radiation, and why is it so dangerous? Stay tuned as we delve deeper into the mysteries of the cosmos and confront the invisible threats that await us in the vast expanse of space. The journey is just beginning, and there's so much more to explore. To understand the dangers, we need to first understand what space radiation is. Let's take a moment to decode this invisible threat. Space radiation, in its simplest form, is energy traveling in the form of waves or particles. It's like a cosmic cocktail party where protons, electrons, and atomic nuclei are the guests, moving at high speeds and constantly interacting. But unlike any party you've been to, this one is happening in the vast vacuum of space, and the guests are not always friendly. You see, on Earth we're shielded from the majority of space radiation by our planet's magnetic field and atmosphere. They act like invisible guardians, turning away harmful particles and absorbing the brunt of this energy. But once you step outside this protective bubble, things change drastically. In space, there's no atmosphere or magnetic field to guard you. Astronauts are exposed to a constant stream of these high-energy particles. This type of radiation is significantly more potent than what we're used to here on Earth. It's like comparing a gentle summer rain to a torrential downpour, and the nature of space radiation is what makes it particularly dangerous. Unlike the radiation we're familiar with on Earth, which can be blocked by simple measures like lead shielding or even a few centimeters of concrete, space radiation can penetrate these defenses. These particles, moving at almost the speed of light, can zip right through the walls of a spacecraft and even through the human body, causing potential damage to cells and DNA. To put it in perspective, imagine a pinball machine. Now picture the human body as the machine, and the space radiation as the pinballs, bouncing around, causing damage wherever they hit. That's the invisible threat we're talking about here. Now that we know what space radiation is, let's delve into the potential dangers it poses. Because understanding the enemy, in this case the invisible, relentless bombardment of high-energy particles, is the first step in learning how to protect our brave space explorers from its potential harm. Space radiation isn't just a theoretical danger, it has real, tangible effects on astronauts. When we think about the dangers lurking in the cosmos, we often imagine colossal asteroids, black holes, or hostile aliens. But the real danger is far less conspicuous and far more insidious. Space radiation, invisible to the naked eye, poses a significant threat to our brave astronauts. Venturing into the cosmos isn't just about strapping on a spacesuit and hopping aboard a rocket. It's about facing a hostile environment, where the rules of life as we know it are rewritten. The radiation in space is unlike anything we experience on Earth. It's more potent, more destructive, and it's everywhere, permeating the vastness of the cosmos. Let's delve a little deeper into this. So, what's the big deal about space radiation? Well, it's not a walk in the park for the human body. In the short term, exposure to high levels of space radiation can cause radiation sickness. Symptoms might include nausea, fatigue, and loss of appetite. It's like having a really bad flu, but you're millions of miles away from the nearest hospital. But the long-term effects, they're even more alarming. Space radiation can damage our DNA, leading to potential health issues like cancer and degenerative diseases. It can affect the cardiovascular system, increasing the risk of heart disease. It can even impact the central nervous system, potentially leading to cognitive impairments. Now imagine dealing with these health issues while trying to carry out complex tasks in an environment that's already challenging enough. Remember, in space, there's no protective ozone layer, no magnetic field to shield us from the onslaught of this harmful radiation. Every moment spent beyond the confines of our planet exposes our astronauts to these potential dangers. But this isn't about painting a doom and gloom picture. It's about understanding the challenges we face as we strive to push the boundaries of human exploration. It's about finding solutions, developing technologies, and learning to adapt in an environment that's not designed for us. These dangers are not just hypothetical, they pose real challenges for long-term space travel. But with every challenge comes opportunity, and mankind has never been one to back down from a challenge. Facing such an invisible and pervasive threat, how do astronauts protect themselves? Well, let's dive into the current strategies used to mitigate the risks of space radiation. It's a bit like learning to swim in a sea of uncertainty, but with the right gear and knowledge, one can navigate these murky waters. First on the list is physical shielding. Much like a fortress standing firm against a storm, spacecraft and spacesuits are designed to provide a barrier against harmful radiation. Materials with high hydrogen content, such as water and polyethylene, are particularly effective as they can scatter incoming radiation, reducing its impact. Additionally, the walls of the spacecraft are often lined with layers of lead, boron, and other materials known to absorb radiation. But as you might guess, there's a catch. The more shielding you add, the heavier the spacecraft becomes, which increases the cost of the mission. So, the challenge is to find a balance between effective shielding and manageable weight. Now let's talk about medical countermeasures. These are strategies aimed at minimizing the damage caused by radiation after exposure. They include the use of pharmaceuticals to protect against radiation-induced damage, the development of nutritional strategies to enhance the body's natural defenses, and the use of personalized medicine to tailor treatments to individual astronauts' genetic profiles. But here's the kicker. Space radiation is not like the radiation we know on Earth. It's more complex, more unpredictable. So these countermeasures are often based on our understanding of terrestrial radiation, which might not fully apply in space. The truth is, while these strategies provide a certain level of protection, they are not foolproof. There are still many unknowns when it comes to the effects of long-term exposure to space radiation. So, further research is needed to fully protect astronauts from this invisible threat. We're pushing the boundaries of our understanding, but there's still a lot of space left to explore, a lot of mysteries to unravel. However, these methods are not foolproof, and further research is needed to fully protect astronauts. So, what does all this mean for the future of space travel? Comprehending and mitigating the risks of space radiation is not just crucial, it's definitive for future space missions, especially those of long duration, like a trip to Mars. Space is not just about the beauty of the twinkling stars or the mesmerizing galaxies. It's also about facing and overcoming the invisible threats that lurk in its vastness. The journey to Mars, for example, is a dream that humanity has been nurturing for decades. But to turn this dream into reality, we need to ensure the safety of our astronauts from the harmful rays of space. Exposure to such high levels of radiation over a long period could lead to serious health issues, including cancer. This is where the role of research and technology comes into play. Scientists around the globe are working tirelessly to develop new materials and technologies that can protect astronauts from space radiation. These range from radiation shielding materials to advanced spacecraft designs that can deflect harmful radiation. Some researchers are even exploring the potential of using the Martian soil itself to shield astronauts on the surface of the red planet. But the benefits of this research aren't confined to space alone. They have the potential to revolutionize radiation protection here on Earth as well. For instance, the materials developed for space radiation shielding could be used to improve the safety of nuclear power plants. The technologies created to monitor radiation levels in space could be utilized to detect and prevent radiation leakage on Earth. Our journey into the cosmos is not just about exploring new worlds, it's about pushing the limits of human knowledge and capability. It's about taking on challenges and finding solutions that can benefit not just space travelers, but all of humanity. As we push the boundaries of human space exploration, space radiation will continue to be a key challenge. But it's a challenge that, with research and innovation, we can overcome.